Hello everyone, we've got a really nice video here on Year 12 AS integration. And this is a absolutely really important key skill and one that often confuses a lot of Year 12s. But it's such an important skill to get right because you can see it's worth a lot of marks. And once you've practiced this skill, it is really quite straightforward. Okay, let's have a look. So basically it says figure 4 shows a sketch of a curve C with the equation y is equal to 32 over x squared plus 3x minus 8, where x is greater than 0. The point P with coordinates 4, 6 lies on C. The line L is normal to the curve C at the point P. The region R shown shaded in figure 4 is bound by the line L, the curve C, and the line with equation x equals 2 and the x-axis. Show that the area of R is equal to 46. Now, the first thing we need to do, and this is a point that really causes students a lot of confusion when they're first learning this concept, is we need to realize how are we going to break down the whole shaded area given in the question into two regions that are going to allow us to answer the question. And in this particular case, the correct way would be to draw a little dotted line down here. And what we're going to do is we're going to find the area under the curve here by integrating between 2 and 4. That 4, by the way, we're given that it's the x coordinate of P. So you drop it down and that's 4. So those are our limits, 2 and 4. And then afterwards, once we've done that, we'll talk about how we're going to find the area of that triangle. So first of all, let's find the area underneath the curve between 2 and 4. Okay, so we write down the equation. It is 32 over x squared plus 3x minus 8 dx. That can be written as 32x to the minus 2 plus 3x minus 8. So integrating, we raise the power by 1, so minus 2 goes to minus 1, and we divide by the new power, okay? Plus 3x squared over 2 minus 8x. So raise the power by 1, divide by the new power, and 8 goes to 8x, okay? Let's just write that in an easier to understand way. Looks confusing with that minus 1 up there and a minus down there. So I've just brought the minus up there and written the x down here just to make it easier so we can avoid any mistakes. Okay, now let's sub in the values. So we're going to sub in our 4. So everywhere there's an x, we replace it by 4 and we evaluate that, which goes to minus 8, add 24 minus 32, which is minus 16. So that's the first term done. The next one, everywhere that there's an x, a 2 goes in. So we're going to basically have a 2 there, a 2 there, and a 2 there. So we evaluate those terms, and that comes to minus 26. And then we have a minus and a minus coming together to make a plus here. So the area underneath the curve in between those two limits is 10. And that's the first important part of the question done. We now know that the area underneath that curve is 10, which is super important. So I've labeled it here as 10. Right, now, how do we proceed? Let's now turn our attention to how we're going to find the area of this triangle here. So in order to find the area of that triangle, there's a number of things we need to do. Quite a few steps actually here. We're going to need to know eventually where this line intersects the x-axis down there. We're going to need to know that coordinate. And the reason we're going to need to know that coordinate is because that will help us to work out the base of our triangle when we come to find the area. So we're going to need to do that. But in order to find out the coordinate of that point, we're going to need to know the equation of this line, L. Okay. Now there are two things that you need to know the equation of a line. You need to have the coordinate of a point and you need to know its gradient. So that means we need to know what the gradient of L is. So we're kind of like working backwards through a chain of logic here. So how are we going to find out the gradient of this line L? Well, we're going to find the gradient because it's by finding out the gradient of the tangent at P. Because if we find out the gradient of the tangent at P, then basically we know that we're going to find the gradient of L because it's going to be negative the reciprocal of that because it's perpendicular, okay? And then how are we going to find the gradient of the tangent at P? Well, we're going to find that out by differentiating and subbing in the x coordinate, okay? So let me just reverse those steps, talk through those steps really quickly again. To solve this problem, we need to know what this coordinate is. To find out that coordinate, we need the equation of L. To find the equation of L, we need its gradient. To find the gradient, we need to know the gradient of the tangent. To find the gradient of the tangent, we need to differentiate and put 4 in. Okay, so let's work through those steps then. So step 1, we're now going to find the gradient of the tangent to the curve at P. So we're going to take the equation of our curve. Okay, there it is. Y is equal to 32x to the minus 2 plus 3x minus 8. We're going to differentiate it. That gives us dy by dx is equal to minus 64x cubed plus 3. Okay, times by the power that's there and lower the power by 1. Times by the power that's there, lower the power by 1, and that constant just disappears when you differentiate. At x equals 4, because we want to know the gradient of the tangent at P, which has an x coordinate of 4. So we sub in 4 for x, okay? And that becomes minus 64 over 64, which is minus 1. Add 3, so that's 2. Okay, that's perfect. Now, step 2, we now need to find the gradient of the normal. And the gradient of the normal is negative the reciprocal of the gradient of the tangent, okay? So if that's 2, this is going to be minus a half. So we've now found the gradient of the normal. So we're getting there now. We are really getting there. So we found the gradient of the tangent. We found the gradient of the normal. So that's perfect. So we're now in a position, step 3, to find the equation of the tangent. Because remember, the two things you need to find an equation of a line are a gradient, which we now have, and a point, which we also have, the point 46. So we're now going to find the equation of the normal, okay, which in other words is the line L. So y minus 6 is equal to minus a half times x minus 4. Sub all of that in, and we've got the equation there of L is y is equal to minus a half x add 8. So that's great. We're really getting close now to being able to solve this. So step 4 then now, or if I've called these little steps in finding the area of the triangle, is where does L cross the x-axis? Okay, this is the key point that we need. Well, something crosses the x-axis where its y value is 0. That's the key to know and remember about that one, okay? So what we say is, let's have a look. We're going to put y is equal to 0 into our equation. So 0 is equal to minus a half x add 8. Simply add the half x over to this side here. We're going to multiply everything by 2, so x is equal to 16. So we've now determined that 16 is the point that we were after all along. And from here now, it's quite straightforward to find the area of the triangle with just one little thing that sometimes confuses people. So the base is 16 times 4. Now, what's the height? And sometimes in this question, I think it's easier to see. But sometimes it's not always that easy to spot, and I'll show you another example in a moment. The height, the perpendicular height of this triangle is actually 6 because it's the y value of P, okay? So therefore, we're going to say that the area of the triangle is a half times base times height. A half times 12 times 6, which is 36. And that's great because that means that the total area of R is the 10 that we found before, and we've just found that the triangle is 36. So we add those two together and we get 46 as required. Okay, so I think that that is a really, really nice example of an integration question. Let me just show you the other context where sometimes students find it harder to spot the significance. Very often you'll get given a question, let's say that's the point A, and that's the point B, and that's the point C, okay? And let's say they give us the coordinate of C is 2, 11, like that. Now, very often they might ask you to find the area of the triangle ABC, and sometimes students find that a little bit tricky to see in this context. But in this context, if they asked us to find the area of this triangle, we'd need to find the coordinates of A and B, where they cut the y-axis, to get the length of the base. But the perpendicular height that we need here to find the area of the triangle is actually going to be given in this case by the x coordinate, okay? Because if you see, if that's dropped down to there, then that's going to be 2. So that is the perpendicular height that you need for finding the area of the triangle. So when they're given a point like that, it can be really useful in finding the area of a triangle. That's an aside. That's just a different little kind of piece of information there. But I hope that you found that helpful. and I will see you all in the next video.